So following on from the previous video, we now need to take care of the case where it's in the negative realm. So suppose you have a sequence where it's in the negative realm. Remember, an plus 1 over an. When you take the absolute value of this is the same as absolute value of an plus 1 divided by absolute value of an. Well, when you look at it like this, you can imagine it as being the magnitude. So this is the magnitude of your next term divided by the magnitude of your current term. So you can see that the magnitude here is 2. The magnitude here is 2, and then the magnitude here in this case, the magnitude is 3. So you can think of it like this. So this is less than 1. So so according to our ratio test, if it's less than 1, the original series will converge. Well, looking at the diagram, it kind of makes sense. It's well, by looking at this diagram, you should have a gut instinct. Well, you should have a hunch that it might converge. Okay, so in this case here, because it's less than 1, the theorem is what the test is saying that it's going to converge. But then let's look what happens when you have a series looking like this. So remember, the ratio test is saying the next term divided by this, but we can opt to view it like this. So the magnitude of the next term is in our example is 7, the magnitude. And then the magnitude of our current one, the magnitude here, is only 5. So you can see that this here is greater than 1. Well, according to the ratio test, the original series will diverge because it's greater than 1. And then looking at the graph, you should have a hunch that that is going to diverge. Looking at this graph here. Well, you could put up an argument. Hang on, you could put up an argument like this. What happens if you have a series looking like this? Well, it's going down, it's going down, it's going down. Yeah, but then what happens if it does something like this? Well, if you look at this limit as n tends to infinity of a n plus 1 over a n absolute, well, you see this is you got to look at it like this. N heads towards infinity, so you don't care what happens around here. You only care what happens when n heads towards infinity. So in which case you got to look at this here. This will be an plus 1. This will be an. So this really boils down to this scenario. It really boils down to this scenario. So hang on. So looking at this, so this is like a magnitude of, let's say, 7 and a magnitude of, let's say, 5. This is going to be greater than 1. So if you have something looking like this, you should have a hunch that it's going to diverge. And then you could put up an argument saying, what happens when it's doing this? Well, it's heading towards, well, here, if you just look at it around here, an plus 1 and then an here. So in this case, the ratio an plus 1 over an absolute. Well, in this case, right at this moment, it will be less than 1 because the magnitude here, let's say this is 3 divided by, let's say, 5, so 3 over 5. Well, you could put up an argument. What happens if a series would do this at first, and then it would do something like this? So here you see here that this is why we have this. This is why we have this limit thing here. Limit as n heads towards infinity. So you don't care what happens when n is small. You only care what happens when n gets very, very big. So in this case, you should have a look at this. This is an plus 1. This is an here. So in this case, this here is 7, and this here is 5. So this is greater than 1. So you can conclude that it's going to diverge. Yeah. Okay.